Okay, so now let's talk about non-deterministic automata. So what was deterministic about deterministic finite automata? It was the fact that from every state there's one and only one place to go to. So from S1, if I see a 0, I have to go back to S1. If I'm in S0 and I see a 1, I have to go to S2. There's no choice to be made there. I just have to do what the diagram tells me to, right? For non-deterministic automata, there is a choice to be made, right? Some states can have transitions to multiple different states for the same symbol, or they can have no transitions at all, so you might get stuck. So what's the formal definition of an NFA? An NFA is a 5-tuple, sigma S, S0, F, and N. The first 4 parameters, the alphabet, the set of all states, the initial state, and the set of all final states, are exactly the same as they are for a DFA. So if you need a refresher on what these 4 terms are, go have a look at the first video again. But the last term is different. The transition function now takes a state, and it takes a character in the alphabet, and returns an element of the power set of S. That is, it returns a set of states. So let's have a look at this DFA here. Sorry, let's have a look at this NFA here. NFA. Clearly this NFA for some characters has got more than one transition, and for some characters has got no transition at all. So from this diagram we can recreate the transition function. If I'm an S0 and I see a 0, I can only go to, whoops, that's not right. I can only go to one place, and that's S1. So you're at the set containing S1. If I'm in S0 and I see a 1, I'm stuck. There's no place to go. So it returns the empty set. Because the set of all states I can transition to using a 1 from S0 is none of them. So it returns the empty set. From S1, if I see a 0, I can't go nowhere. So again, it's the empty set. From S1, if I see a 1, I can go to all the possible states, because I can use a 1 to go to S0, I can use a 1 to go back to myself, or I can use a 1 to go to S2. So the transition function, given the state S1 and given the character 1, returns all 3 states. And so similarly for the last case, S2 can only go to itself for a 0, so it goes to the set containing S2, can't go nowhere for a 1. So that's what an NFA is. How do we define acceptance for an NFA? We define acceptance if a path to a final state exists. That is, the NFA A accepts a string alpha if there is some sequence of transitions to follow such that we end in a final state. So for example, the string 0, 1, 0, 1 is accepted. Why? Because there's a path of transitions from S0, read a 0 to go to S1, read a 1, and I'm choosing to go back to S0, read a 0, go back to S1, and then read a 1 to go to S2 and then finish. There is some path that works. 0, 1, 0, 0 is rejected, and if we want to show that, we have to show every possible path fails. We have to try them all, right? Because if we want to show no path exists, I have to show any possible choice of path fails. So from S0, if I'm reading a 0, there's only one place to go, that's S1. Okay? If I'm reading a 1, well now I've got 3 choices, right? So I have to try all 3 choices. I could go to S0, or S1, or S2. So under a 1, I can go to S0, or S1, or S2. Now I've got a 0, so now I've got to check all the possible options. If I'm in S0 and I see a 0, there's only one place to go. If I'm in S1 and I see a 0, I'm stuck, so that doesn't work. If I'm in S2 and I see a 0, there's only one place to go, back to S2. And then for the second 0, back in S2 again. Oh, this is accepted. Fancy that. I was thinking it was going to fail. Never mind. 0, 1, 0, 0 is accepted because you can go 0, 1, 0, 0. But if we were looking at some string that was rejected, what's a string that's rejected for this NFA? 0, 1, 0, 0, 1, 0, 1, 0, 0, 1. Yeah, 0, 1, 0, 0, 1 looks like it fails. Okay, so let's check that fact. So we try all the options. I'm in S0, I can only go to S1. I'm in S1, I've got 3 options. Okay, and then from these options, where can I go? Well, let's try the bottom path. So S0, read a 0, go to S1. From S1, read another 0, I'm stuck. So that didn't work. So 0, 1, from S1, read a 0. Looks like I'm stuck, because S1 can't go anywhere from 0, so that's no good either. S0, read a 0, go to S1. S1, read a 1, go to S2. S2, read a 0. I can only go to S2. S2, read another 0. Go back to S2. S2, read a 1. I'm stuck. So I can see I branched every possible option and none of the options work. So I definitely know 0, 1, 0, 0, 1 is rejected. You can see in the worst case, for a string of length n, determining if a NFA accepts or rejects, can take exponential time. Can take big O 2 to the n time. Or possibly worse than that, right? Because from each state, if I branch at every possible state, then this thing's going to blow out like a tree, right? So from S0, I got 2 places, and then from those 2 places, and then from those 2 places, and 2 places, and so on. And that's only if there's at most 2 transitions from each state. If there's 3 transitions from each state, or 4 or 5, this could be even worse. It could be 3 to the n or 4 to the n, right? So in the worst case, this thing's going to take exponential time, which is no good, right? So we'd like a way to be able to evaluate NFAs quickly, which we'll cover in the next video.